Hello, Yasser. Abdullah, this is your first class? Am I audible, guys? If you can tell me your name, then I'll remember you. Okay, okay, now. All right. So you guys were in the last class, right? You did conjugate of your complex numbers. Okay. Any doubts from the last class? Yasir, you are not responding at all. Okay. So let me give you a question. Please try to solve it and see. Okay, Yasir. No issues. If Z is 3 plus 4i, what is conjugate of Z? Who can tell me? Absolutely correct, Abdullah. Right? Yes, sir. Okay. Can you guys please see this? What you get if you multiply Z with Z bar. Okay. Z with Z conjugate. What you get after you multiply this? Tell me the answers in the chat. No, Abdullah, please multiply and see. Yasir, you need to solve further, right? What is 3 square? What is 4i square? Please solve that. Get the answer, proper answer. Right. So this is a plus b and this is a minus b. So a plus b and a minus b formula is a square minus b square. So this is 3 square minus 4i whole square. So this is 9 and minus 16i square. What is the value of I square? We did this in the last class. Minus 1. Very good. So 9 and minus 1 minus is plus 16. This is 25. Right? So please remember this. This is extremely important. If Z is a plus ib, then Z bar is a square plus b square. Very important. Okay, note it down. Yes, Abdullah, the answer is 25. All right, if Z is a plus ib, then Z conjugate of Z is equals to a square plus b square, the coefficient square and addition. That's it. All right. Done, both of you? Please solve one question. The question says, if a plus ib is equals to x plus I whole square upon 2x square plus 1. Prove that a square plus b square is equals to x square plus 1 whole square whole divided by 2x square plus 1 whole square. Okay? Please solve this. Hello, Afnan. Afnan, you are late in today's class. No issue, but please be on time from the next class, right? You might miss few crucial things if you be late. Alright. We did conjugate in the last class, and please remember this property that if z is a plus ib, and you find out z multiplied with z bar, conjugate of z, you get a square plus b square. All right. Please note it down. Then try to solve this question. I'll give you 2 minutes. All right, Yasir. See, this is not about LHS RHS question. All right. Just look at the questions and look at the data, what is provided. All right. They are asking you if this is equals to this, then prove that this is equals to this. You can start from anywhere. All right. Let's start from LHS. Right. A square plus b square. This value they are asking, what should it be? What is the data given? This is the data given to you, right? Yeah, sir. Okay. Suppose I take this data, z is equals to a plus ib. How can I reach a square plus b square from this data? Z equals to a plus ib. How can I get a square plus b square from this? Z equals to a plus ib. I told you the property few seconds before. Can I say z conjugate of z will be equals to a square plus b square? Yes or no? Absolutely correct. So can I say this is z times conjugate of z, right? Okay, this is clear. Now let's start with this. A plus ib equals to x plus I whole square whole divided by 2x square plus 1. So a plus ib, if I multiply with conjugate of this, a minus ib, then can I do this also? X plus I whole square whole divided by 2x square plus 1 multiplying with the conjugate of all this. Yes or no? This is to be proven, right? But given is this x plus I whole square. I started with the given statement. All right, a plus ib equals to x plus I whole square. All right, yeah, sir, this is clear. So on the left hand side, we got a square plus b square. Let's see at the right. Suppose this is also z and this is conjugate of z. So can I say if I simplify this thing, then this will also be a square plus b square? Yes or no? This is also a complex number, right? Okay. So x plus I whole square, and this denominator is just a real number. So I can square it like this, no issues. Conjugate of this. Do you remember the properties, everyone? Z1, Z2 conjugate, I can write as Z1 conjugate, Z2 conjugate. Yes or no? Okay. So can I say this is x plus I and conjugate? So this is x minus I and x minus I. So x minus I whole square. Is this thing clear? Everyone? And in the denominator, we have 2x square plus 1, 2x square plus 1, 2x square plus 1. No. Okay, yes, sir. Let's start with the question again. We have a plus ib as x plus I whole square whole divided by 1 plus x square, I believe, or 2x square plus 1. Whatever that was, 2x square plus 1. All right? Yes, sir. Okay. If I take z equals to x plus I whole square whole divided by 1 plus 2x square, then z conjugate, can I write x plus I whole square whole divided by 1 plus 2x square conjugate? Okay. Now, do you remember this property? Z1 upon Z2 conjugate is Z1 conjugate upon Z2 conjugate. And same with multiplication. This is clear? Okay. So can I break it down like this? X plus I whole square conjugate 1 plus 2x square conjugate. Further, I can write this as x plus I conjugate, x plus I conjugate divided by conjugate of this. There is no imaginary part here. There is no I part. So this will remain the same, right? 5 conjugate is 5 itself. This is correct. Okay. Now in the numerator, what is remains? X minus I into x minus I upon 1 plus 2x square. So this is x minus I whole square upon 1 plus 2x square. Yes or no? Okay. Now this was our given quantity, given data. I can say a minus ib is equals to x plus I upon 1 plus 2x square whole conjugate. If I multiply these two equations, on the left hand side, I'll get a square plus b square. On the right, I will get x plus I whole square upon 2x square plus 1. into the conjugate value we just found out like this, x minus I whole square whole divided by 1 plus 2x square. Yes or no? Yes or no, everyone? Okay. Now we just need to multiply and you will get the answer. And this is one way to solve it. I will tell you the other way also. If you guys feel like, oh, bhai, bahut complicated ho gaya. It's not that complicated. In the numerator, the multiplication is very simple. This is 1 plus 2x square whole square. In the denominator, this is x plus I whole square into x minus I whole square. So can I write this as x square minus I square whole square upon 2x square plus 1 whole square. I square is minus 1. So minus minus plus. So 1 plus x square whole square divided by 2x square plus 1 whole square. This is the thing to prove. Yes or no? All of you? Okay, Yasir, Afnan, Abdullah, this thing is clear. All right. Do you guys need to know the other methods? Please note it down. Then I'll tell you the other method also. No worries. From here. All right. Start with here. Then I'll move it downward. Tell me when you are done. All right. Clear, everyone? Yasir, Afnan, this is done. Afnan, you are not responding. You are there in the class. All right. So not in all the questions you have to solve like this. For that, there is another thing in complex number which is called modulus. Please write it down. Modulus of a complex number. All right. Suppose there is a complex number z equals to a plus ib, then its modulus is denoted by mod z, and that is equals to a square plus b square root. All right, very simple. Just take the coefficients, square them, add them, take under root. You will get the answer. Very simple. Note it down. For an example, if you have z equals to 3 plus 4i, then mod z will be 3 square plus 4 square under root, so 5. All right, and it is always positive. Never take the negative value. Note it down. Tell me when you are done. All right. I just like magic. I goes vanishes. All right, Abdullah. This is a real part square plus imaginary part square. All right. Yep. Clear? No doubts in this. So please solve this. Few questions for you. 3 minus 4i, 12i plus 8, 6 minus 8i. Yes, but actually, when we are taking modulus, we do not even consider I. What this is actually, mod z is equals to real part of z square plus imaginary part z square under root. I is not even considered. All right, you will understand why. So, all right, in the next class or in today's class, hopefully. So please solve these 3 questions. Got the answers, everyone? Okay. Yasser. This is 5. This is 10. And this is 12 score is 144. And this is 64. All right. R 208 under root 210. Yasser, how are you getting? You forgot addition? Okay. No problem. All right. Best don't make silly errors, right? We do not want to give away our marks. Abdullah, Afnan, got the answer? Afnan, Abdullah, got the answer? Yes or no? Just solve this question. No worries. I'll give you 2 more minutes. Afnan, please solve it. Done, Afnan? Okay. So modulus is also pretty simple. Few properties of modulus, just like conjugate. Right. Right. If you take Z mod or take minus Z mod or take conjugate of Z mod, they are all equal and it's a square plus b square under root. All right, it doesn't matter. Just like in conjugate here also, you can divide the modulus like this. All right. Just like conjugate, you can separate them also. In one property, I already told you. What is the difference? Second one anyway. What is the difference? All right. The difference is, suppose you have a question like this. Z equals to a 3 plus 4i upon 5 plus 6i. They are asking you to find mod Z. Okay. If you take mod like this and you do not use this property, then what you will do? You will simplify. You have to simplify because you do not know the property. After simplifying, you will get something like this, a plus ib, then you will find mod. But if you know the property, then you can know this 3 plus 4i whole mod, 5 plus 6i mod. So this is 9 plus 16 under root, and 5, 25 plus 36 under root. Got it, Yasir? Okay. And the last one, I already told you, z bar is mod z square, right? A square plus b square. This is very important. All right, you can write it like this also. Z equals to mod z square upon z bar. Please note it down. Tell me when you're done. Okay. Let on one type of question there is that is called multiplicative inverse. All right. Very simple. If z is a complex number, then its multiplicative inverse is 1 upon z. All right. Very easy. So if you have z equals to 3 plus 4i, then multiplicative inverse will be 1 upon z, which is 1 upon 3 plus 4i. Now you can simplify this, right? This will be the multiplicative inverse of z. Do not just leave it like this. I've told you also, for some reason, we do not like complex number in the denominator. All right, so you have to rationalize like this and solve further. Is it clear, everyone? What I said? Okay, please note it down. Yes, Abdullah. Have you noted this down? Okay. So remember one thing here. If the multiplicative inverse of z is 1 upon z. So can I multiply conjugate of z like this and divide by this? So this becomes conjugate of z divided by this is mod z square. Yes or no? Is it clear what I did here? Okay. So remember multiplicative inverse, if you have to find, use this formula, conjugate of z divided by mod z square. So in the previous question, we have z equals to 3 plus 4i. Multiplicative inverse, I can say z dash is equals to conjugate of z upon mod z square. Conjugate of z is 3 minus 4i. Mod z is 3 square plus 4 square under root. So if you square, just 25. You do not have to solve many complex numbers. Is it clear? Yasir, Afnan. Okay. Please note it down. Tell me when. Then solve few questions. Find the multiplicative inverse of z equals to 3 plus 2i. Okay, Yasir. Did you square 2 times? Multiplicative inverse z dash will be this upon mod z square 3 minus 2i whole divided. Mod z is 3 square 9, 4 square 4 under root 13 square is 13. Did you square 13 again? Right. Now is the correct answer. Everyone, is this clear? Modulus is clear? Abdullah, Afnan, is it clear? Modulus and multiplicative inverse? Okay, few questions. Find multiplicative inverse for the following. This is for homework. Z equals to 2 plus 3i whole divided by 1 plus I. Z equals to 3 plus 4i whole divided by 5 minus 6i. All right, two questions for homework. Please find multiplicative inverse for the following. Write it down. Tell me when you are done. All right then. This is all for today's class, guys. Take care. See you in the next class. All right. Please complete the homework. All right. Yes. Abdullah, you had to solve this for homework. All right. Yes. Complete this one for homework. And you'll get some assignment also. No worries. All right. See you in the next class. Same to you. Afnan, any doubts? Which part? The last question? Okay. Are you clear about conjugate and modulus? Okay. So multiplicative inverses, just use this formula. One minute. Suppose z equals to 1 minus 2i, and they are asking you to find multiplicative inverse. Then suppose I say multiplicative inverse is z dash. The formula is very simple. Conjugate of z upon mod z square. So if z is this, then can you tell me what is conjugate of z? What is conjugate of z? 1 plus 2i, right? The question is 1 minus 2i. So 1 plus 2i. Now what is mod z? What is mod z? Right. Mod z, see, if z is a plus ib, then mod z is a square plus b square under root. So here under root 1 square plus 2 square. Clear? Okay. So this is root 5, and we need mod z square. So if I square this, then the answer will be 5. Just put the values here and you'll get the answer, right? 1 plus 2i divided by 5 is the answer. Got it? All right then. This is all for today's class.